Hello, hello. Welcome. Thanks for joining me today. My name is Dan Willoughby. I am the Developer Advocate for Storj. Today I have nothing really set in stone or planned, so please type your questions in the chat and we can go and answer those questions. But for sake of having something that we can all enjoy and look at, I'm going to do a walkthrough of how to set up Rails 7 with Storj. So we'll just give it a minute here, make sure everything is working, and go ahead and type in the chat where you're joining in from so I get a sense of where everyone is, and also just to check to make sure everything is working. For those who are just joining, this is a virtual tech lab. You can ask any question you would like, and I will do my best to answer it here or give you resources to get some things figured out. So what I wanted to dive into first was just how to make a Rails 7 app connected to Storj. So the process is relatively straightforward. So we will dive into that here in just a moment. Hey, from India. Awesome. Welcome, welcome. I am joining from Utah, actually, in the United States. So what time is it over there in India? Probably pretty close to evening or early morning. Absolutely type your question in the chat and I will get to it. I'm just going to switch my screen now. Maybe. Okay. So I was going to show how to bootstrap a Rails 7 app and get it connected to Storj. Relatively straightforward example of how Storj has an S3 compatible API, and you can connect it to most anything that has that capability. 10:30. Wow. We are almost exactly 12 hours apart. That is awesome. Okay, so the first thing I need to do is first install Ruby. What I have done here, I have Ruby 3.1.2, and I've already previously set up my gem environment. You can see a little bit more details there. I'm not going to go into the basis of how to set up Ruby, but what I have used here specifically is Cheruby to install this. And so you can dig into that a little later if you'd like. But so to get started with Rails, we simply go with Rails new. And I'm going to call this ActiveStorage just because behind the scenes, Rails is going to use ActiveStorage, which kind of hides all the complexities with using a object storage provider. And you'll see very soon why that's the case, but let's go ahead and hit enter there. And Rails is going to generate a ton of files, really just setting up the framework here. But if I go ahead and go in there and just do a git status, you'll notice that there's lots of files, lots of directories. So Rails kind of has a learning curve. So if you're not familiar with a lot of these things, there is a lot of resources out there to get started with Ruby on Rails. But for purposes of this video, we just want to show you how easy it is to set up SDKs or libraries that are compatible with the S3 API with Storj DCS. So I'm going to dive into that now. First, I just want to do an initial commit here. And that will get me in a place that is good. So the next step in installing ActiveStorage is basically this command here, ActiveStorage install. What that'll do is, if we do another git status, create this migration to set up these tables in our database to track certain things about where our files are going to be stored and various other things. Under the hood, ActiveStorage is going to use pre-signed URLs, so we will also show you that near the end how that's working, but for now I'll just run Rails DB migrate to go ahead and create those tables. And you notice that it made 3 tables here. We have ActiveStorage blobs, attachments, and variant records. And then the next step is we'll want to get the AWS SDK. So I'll go ahead and say gem AWS SDK S3. I'm going to go ahead and type on require false there. And then the bundle install will get me that dependency, installing the SDK there now. And next, we'll need some credentials for ActiveStorage to use. And so what we'll need to do is go get ourselves a storage account. So I will go to storj.io. I'm going to go ahead and hit start for free. So on Storj, you get 150 gigabytes for free, which is very generous. And what that allows you to do is try out your integration, make sure it's working well for your use case. And then afterwards, you can upgrade and pay as you go with your credit card, or you can pay with storage token, which is, I believe you get a percentage back of token if you choose that route. So I'm going to go ahead and type a secure password here, being careful not to leak it. I did that on one of the previous streams, so I had to change that password. But all right, so now the next step here is just to verify my email. So I will go in, and it looks like, yep, it's already here. That's what this looks like. I'll confirm that, and that will log me in. So for today, I am going to just use the web browser to get my S3 compatible credentials, but you can absolutely use our uplink CLI. There's various ways to integrate it. The biggest perk is you get end-to-end encryption, which means that Storj can't read your data even if it wanted to. And on the web browser, you get server-side encryption. So we've gone to great lengths to make sure your data is yours and we can't see it. So there is a link here that you can read about the extra steps that we took to make sure that this is done correctly. But behind the scenes, essentially, we compile some Go code and run it in the browser to make sure when you type that password to protect your data, and you'll see that here in just a minute, that it is done on the client side. So clicking continue to web, here it wants me to generate a passphrase, and I'm going to just type a very insecure one just for the purposes of the demo, but you would want to make sure that you type a secure password there. So that password is what encrypts your data. So you need to make sure you don't lose it, because we cannot rescue your data or reset that password specifically. All right, so next step here is I'm going to go to access on the left side, and I'm going to choose create credentials, S3 credentials. And I want it to, you know what, I'm a little bit ahead of myself. I actually want to create a bucket because I'm going to make sure that I scope my credentials just to this bucket. So there, I've created a bucket, and you could think of those as just like a file on your, or like a folder on your desktop. It's a little like if you've used object storage before, it seems like it's just like a file organizer like Finder, but it actually behind the scenes is just a key value store. So this bucket, you could liken it to a folder, but behind the scenes, it's really just saying this file is stored at this path. The path being here, first ActiveStorage, and then if it was like hello.txt would be the next part of that path. So now that that bucket is created, let's go ahead and jump over to Access. Feel free to follow along too and ask questions as you go. But I'm going to give it all permissions. You can limit this. So say if you were conscious of your data being deleted, you didn't want that to happen, you could uncheck delete here, and then this access token could not delete anything. And then we will scope it just to that bucket, so we don't have to worry about if it touches other things. So that it's a good way to separate your data into manageable things. And then just a name of this credentials, I'm going to just use the same name as the bucket. And then once again, that server-side encryption there. And for it to be easy to see what you upload to the bucket from the credentials, you'll want to make sure the passphrase is the same. Once again, there is my very insecure password. You'll want to make sure you have one that is much better than that. But all right, so now I have my credentials. So what we'll want to do is edit the credentials in Rails. And so what this is a git crypt. The technology behind here is git crypt. So this is also a secret you don't normally want to leak on a stream, but it is okay. This is just going to be localhost. But I am actually going to copy this here. And very much like AWS, we will want the access key, which is right there, and access secret key, which you have to be very careful not to let publish the secret key anywhere. And that's what this credentials file gives you, is that ability to store these in your version control, or like your Git. You can store your credentials without giving away that secret information. So for example, if I would look at the contents of this file, let's go ahead and do a vim. See, it's just gibberish. There is no secrets there. So the way that that is working is you'll notice that there is also this master key. And this master key is used to decrypt this file. And so in our git ignore, the master key is set. So when you deploy to production, you'll want to make sure you copy that master key in that config directory, or set it as an environment variable. Just one thing to note there that may trip you up. So once those credentials are set, we can now go into configuring the storage service. And so the way that we do that, I believe, is in this storage.yaml. And I'm just going to riff off of the Amazon one, makes a few minor adjustments. So I'm going to call it Storj. We use behind the scenes the S3 API, so we'll leave that there. And as you recall in the credentials, I did rename that top level to Storj, but I kept access key and access secret key the same. Storj is actually global by default. So when you upload a piece to the network, it is broken into approximately 80 pieces, and it is spread through parts of Europe, a little bit into Asia and the United States. And so you get global redundancy by default. So to achieve this on S3, you would typically have to choose your availability zone or your region. So the most common one is like Virginia or Oregon. So to get that same performance in Europe, you would have to duplicate your data into Europe. And the way that storage is different is we use erasure coding. So like I said, those 80 pieces are spread throughout the world, but we only need 29 of those to get your file back. And so that redundancy is built in. But not only that, if you're retrieving that file from Europe, it will use those nodes closest to you to make sure that your file is getting to you as fast as possible. So ActiveStorage was the name of the bucket. And just one last thing to tie this off is we will need to set the endpoint to gateway.storageshare.io. And we are good to go here. So the next thing we will need to do is configure our environment. So let's just stick to development here, but ActiveStorage service. If you're in development, it will mimic what it would do with a cloud storage provider with like your local file system, but you can also switch this to a cloud provider such as Storj. So that's what I'm doing there. And now this is good to go. So next we will need to go ahead and let's just commit this and say set up ActiveStorage. Okay, so now we'll need to generate something to have to like upload a image and view that. And so Rails has a built-in scaffold thing that I'm going to use that will just give us a simple app. There it's creating a bunch of files. But so if we go ahead and start our server, actually one final step here is I need to make my default route to that scaffolding I just created. So a lot of conventions going on here, but once you learn them, it is powerful in that you get a ton of speed. So I'll go ahead and run Rails routes, and wow, not what I expected there. Oh, the reason is I did not migrate my database yet. And I was a little premature in making that change. So let's go ahead and migrate the database, and then we can set the route to that, the route path to that, and then Rails routes should work here. Or not. Okay, let's go ahead and look at what we have. So app controllers, names controller, do have an index. Okay. So looks like I have a question in the chat. What kinds of speeds can we expect in upload and download? And so the answer there is it depends. So if you are uploading to the S3 compatible API, the bottlenecks there would be either your upload or your egress from your home network. So if you have like a 500 megabit per second upload, you will max out that connection from that specific server. If you are then using the S3 compatible API, the bottleneck could be the actual gateway, we call it, that takes that file to the storage nodes across the globe. So, but if you use that uplink, that native integration that we briefly saw at the beginning, you can expect to basically max out your connection, is what is typically seen by those who have integrated that. So the best answer I can give you is to try it out and see how it performs for your use case. But we have seen speeds up to, I believe, 8 gigabit. So certainly great question. And that 150 gigabytes of that free tier helps you make sure that the performance is what you expect. And that's why we offer that generous tier there. Okay, great question. Thank you. I forget now what I was doing. We were just about to see why this wasn't working. Okay, so for now, let's just comment that out, because apparently something is happening. So let's just get our local host. All right, so we do have Rails running here. And you do have a names controller. And if I do get names, okay, so that's working. So then why can't I set the route to that? Oh, because it's not in quotes. All right. That's, it's always the little things that trip you up. All right, so now if I go to the root here, I will get the scaffolding. So what I want to add to here is to have a form. So in the names, I believe it's called form. I want to add just a little code to make sure to update or to include an image here. So I'm going to go ahead and call it my main image. And I'll give it a file field, and that'll be my main image. Okay. And then if we refresh that, now we can choose a file. This will not work though, but I'll just kind of show you some of the errors you may run into. Network. Oh, right there. Okay, so if I hit create name, it's going to just create the name, right? There's two things that didn't happen. One is the, if you can see here. Oh, scroll up. We got the main image submitted, but it wasn't stored in the database anywhere. So the thing that we need to make sure we add is to our model is this has one attached main image. Okay. And what that'll do is give us some helper methods. So if I open the Rails console here, you'll see that if I do n equals name dot first, this will now have like has or image, main image. Yeah. So now it has a main image. Whoop. For that one, the very first one, it wasn't updated because, for one, we didn't have this on the model, but in our controller, which is the thing that handles requests from, you think of it as like the API. When this was, it hit this create endpoint, and it will create a new name based on these params, which is a private helper function here below. And it is only permitting the param name. So that is another reason why it wasn't uploading. And so I need to change this to permit and have the main image included. There we go. And then we should be able to go back to names. Let's create a new one. Call this test1. Go ahead and choose that file again and create the name. So there it was uploaded to Storj. We didn't quite see it behind the scenes, what was happening, but what it did was it queued up that upload. The file went to my server, and then it was uploaded to the storage network. So if I go ahead and go into the map bucket, we'll see here that that image has been uploaded here. It doesn't, usually this preview would show the file, but Rails doesn't give extensions. It just gave this blob name. But right off here to the side, you can see this map. Man, it's not big enough, but you can see these little dots of where that file was stored across the world. So huge concentration in Europe, spread out across the United States. So if I were to download this file from Utah, it would pull from most of these nodes here where that connection is fastest. And we overfetch, so we pull from maybe 80 nodes, and then we cut some of those short based on which ones are performing the fastest, and then we just pull from the fastest 40. Oh, more questions here in the chat. So basically what I read, as compared to traditional cloud services, Storj offers cheaper prices, better speeds, more resilient backups, both in terms of number of storage nodes and also geography. If you had to pick one, what would be a downside of Storj compared to AWS? Okay, yeah, great question. So your research is great. Storj has $4 per terabyte for its pricing, and $7 per terabyte for egress. So if we want to dive into, this a little bit. Oh, that's not where I wanted to be. I have a slide for this that I like to show. And I'm going to pull it up. Maybe. Here we go. I believe it was this one. Yep. Okay. So Storj is on par with that multi-region. Like explained earlier, you typically have to pay a lot more to get that with traditional providers. Performance, I believe this is, sometimes these slides get out, but it's 10 to 24 is what we've achieved. Availability 95%, durability 11 nines, and so a lot of these is pretty on par with S3. The one drawback I would say, if I had to choose one, is that if you are using the native uplink to upload, you have to upload 2.7 or about 2.5x to get that distribution through the network. So what that means, if you have a 1 megabyte file, you would have to upload 2.5 megabytes in order to finish that upload in the native integration. But if you use the S3 compatible API, you would upload that 1 megabyte to the gateway, and then the gateway would then distribute it through the network. So with people that have that limitation, we typically suggest that they use the gateway or the S3 compatible API to upload, and then use the uplink to download, so then they can utilize that entire network and get that consistent global performance in United States or Europe. All right, and then the other downside, so you say AWS there, but so storage is just like a comparable to AWS S3. So what some people are looking for is they want a complete platform, right? They want to have a virtual machine to do some like compute tasks, like I'm showing here in Rails, like, take this file, look at the params, like some sort of API, right? So some virtual machine, you're not going to be able to host virtual machines on Storj. But if you have high cost in S3, your AWS costs, AWS S3 costs, you will find that a drop-in replacement with storage is a very good way to cut those costs and not give up on that availability or durability. So just to explore that a little bit further, often we're compared with like Wasabi or Backblaze. So what you pay for when you store a file with them is a single copy, like either rated or erasure coded across like 3 hard drives. So in a single data center. So if I upload to Wasabi today, my file would end in like the Virginia data center, and I may have 3 copies within that data center. So the advantages is they are also cheaper. I believe they're 5 terabytes or $5 per terabyte to $11 per terabyte. Wasabi specifically has a minimum storage, so you won't, if you delete that file within the first 90 days, or let's say you delete it after 20 days, you're going to pay for those 90 days of storage at a minimum. And then Wasabi also says they have free egress, which means how often you download your file. But it's limited within a fair use policy. So for Wasabi specifically, if you download your file more than once in a single month, you will pay extra money, whereas storage is locked into that $7 per terabyte for egress. Backblaze, I believe, is $10 for egress. But the risk that you run with the single site providers is that if a single hard drive goes down, it'll be fine. They'll repair that data. But if their entire data center goes down, you're out of luck. Your file's offline. So AWS is a little bit different in that they replicate your data within a region. So there may be 1 or 2 data centers where they copy those files with either RAID or some type of encoding. But you're going to pay arm and a leg for that, like 18 to 23 terabytes per month. And egress is up to $90 per terabyte. And you also lump on the API request fees. And typically when people ask me about this, they're like, oh, well, there's these Glacier options where you can get it down to like $2 or like $3 per terabyte. But you're really, unless you aren't like Glacier has a meaning attached to it. Like you don't want to touch those files because the retrieval fees often, like if you retrieve that file twice when it's in Glacier, it's going to likely exceed the cost of this as if you just used a single region. And they also have some like smarter tier where it like optimally chooses the right storage tier for you. But like if you really like dig down into the numbers and the math, like it really just equals out to this 18 to 23 terabytes per month. And maybe the next virtual tech lab I can dive into those costs a little bit more. But like I was saying, Amazon, Google, and Azure offer multi-region. Actually, Backblaze just released multi-region as well. But what that does is you pay for an additional copy. So say this first copy is in United States, and then this second copy would be in Europe. You would pay $46 per terabyte for that. Just like getting crazy, right? And so you're now up to 46 terabytes per month just so that you can have reliable performance in Europe and United States. On top of that, you're paying $90 per terabyte for egress and API request fees. Well, you're going to burn through your money. That's the risk here. Storj is different in that we give you those multi-regions by default because we have a decentralized model. Our pitch to the world is bring your unutilized hardware, connect it to our network, and we'll compensate you fairly for what we use on your devices. And what that allows us to do is to have approximately, now we have 15,000 storage nodes across the world where we can put pieces of files so that if one single node goes down, the risk of your file is negligible. Like nothing will happen if like even if 10% of the nodes storing your file goes down, it's just fine. So, and that all comes with $4 per terabyte per month and that $7 per terabyte egress. Also, no API request fees. There is a segment fee that isn't listed here, but that usually deals with if you're storing a lot of small files on the network. That's not the best use case for storage. But if you got a normal like either backups or large files that you're using storage for, you usually don't notice that. And on top of all of this, it is open source, so you don't have to trust the code. You can go inspect it for yourself. We're a very transparent company in that sense. And just zooming in a little bit, storage is $4, $23 AWS. Often other things are tacked on there, but the biggest thing is you're getting multi-region storage for $4, where you're gonna double that cost each time you add a region on all these other providers. I think that's what I wanted to say there. So it's really the question comes down to, well, how is that even possible? Well, so like I said, we have those across the globe. They have like a server with 5 terabytes on it, right? And they're only using like a terabyte, and so they can make those 4 terabytes available on the storage network, and we can utilize that space. And what we do as a company is we generate demand for that storage. So we have partnerships with like TrueNAS or GB Labs, some of these media and entertainment companies, and then they will use our either uplink tool or our S3 compatible API to store those files. And then the satellites just handle logistics to make it like this nice web console to view your files, but also that S3 compatible API. And it'll also repair the network so that you kind of have this logistic handling part of the network, so that it, from the customer's perspective, they are getting an S3 compatible storage or a global redundant storage at a fraction of the cost. And then the storage nodes, on the other hand, don't have to sign individual contracts with customers or anything like that. They receive payment from the satellites that they opt into, and it handles that the satellite handles making sure that the data is redundant, and also managing like access controls. So the other typical question is, well, then if I'm storing my files on these basically strangers' servers, how is that secure? Well, the answer is encryption. First, we encrypt the file, and with that encryption passphrase that you provide, and then it's split into those pieces, and then it's distributed, and then on the way back, it is decrypted. So no single storage node will have more than one piece of your file. So even if they decrypted it, they would have to go and find 70 plus storage nodes and get the files from them to even reconstitute the file to where it can be decrypted. So a lot of protections just built in from the ground up. Cool stuff. A little bit of a tangent there, but I think it was worth it. All right, we are pretty close to having our Rails server connected to Storj. We have uploaded the file, shown it in the web console. What's left here is to just view the image, essentially. So I'm just glancing at my notes here, make sure I didn't miss anything. Okay. So I will want to open this view and the show, and here it will basically want to include image tag is how we do it, and then the model, and then just tack on that main image. Okay, and then I already know that we're gonna have a massive image, so I want to add some styles. I forget the name of where it is though. It's in assets. Yeah. Style sheets. So I'm just gonna make sure my image tags have a decent size width here. Okay. So if I refresh this, I now have that image there. As you can see, it is redirecting to my server. So if I grab that link out, now you can see that it is, after it redirects, it is on ActiveStorage.gateway.storage.share.io. So the last thing I wanted to show is how you can make it go directly to Storj. And it is, I have to get some JavaScript to do that, and I didn't copy it in my notes. So what I'm going to go do is glance at this one. I believe it was app JavaScript. Oh, you know what? I'm just going to have to change directory to there because not older, old. And then I think it was at Rails. Okay, yep, the import map. So I'll need this JavaScript here to in order to enable directly to Storj. So that's what that is. Pinning to the CDN that has this JavaScript compiled. So save that, close my notes there. And then in my form view, I will need to have, I also don't quite remember. Direct upload. Yep. Okay. So I want to say the direct upload true. And then the last part will be I need some initialization code. So I think it was like this. Not ActiveStorage. There it is. App JavaScript controllers application. Okay, so app application.js. There it is. Oh, wait. App JavaScript controllers. There we go. App JavaScript controllers application. Okay, here we go. That's what I was expecting. And so now we include or import as ActiveStorage from @Rails. That's ActiveStorage. And then to make it all come together, ActiveStorage start. Okay. So a little bit of a change, went through quite a bit there, but let's see if it works. So back to names. We will do a new name. Let's call this direct. Choose a file. Let's do I don't know, this one. Okay. And then I will clear out my network, make this a little bit bigger. Just to make sure this form has that direct upload on it. Direct upload. Awesome. And then we will upload. Okay. So what you can see here is that it went directly to Storj instead of through the server, which is awesome. Because in one of the other virtual tech labs, we went through why the difference between proxy and pre-sign, and what if you are proxying your traffic through your server, you're paying for that egress from your server to your object storage. So if you could do direct, it'll go to your server first just to get like this URL, this pre-signed URL. Then it'll go back to your web browser, and then it will upload directly. So that is something you definitely want to implement if you have large files. All right. Yeah. One more quick. Yeah. So now we are into question mode. That was all I wanted to show with how to set up Rails on S3. Very straightforward. I will also upload this code after, so you can take a quick glance at that. But yeah, let's dive into the questions here. Sorry for the barrage of questions, and thanks for your patience. Hey, that's what this stream is for, is to give you a chance to come and ask your questions. So I'm super thrilled that you're asking them. Just a few follow-up ones. My previous questions about downsides was to understand why storage isn't more widely used. It seems practically much better. And secondly, who are these storage nodes actually? Normal people using hard disk space or big data centers? Okay, great. Let's dive into the first one. So why isn't storage more widely used? There's a two-part answer to that. The first part is we went through a pretty big rewrite back in like 2017 to 2019, and that's the V3 version of the Storj network. So during that time, people could use it, but it was still kind of experimental. And then teetering into 2020, the network became ready for production, and so then we were starting those sales cycles, those conversations with bigger companies. And just just a little bit of background on just object storage in general. To win these contracts and these like these bigger deals, they often look at how long you've been around in the market. So when the network was still relatively new, back 2019, 2020, they were a little bit hesitant because they weren't sure how long it was going to be around. But then now that we have at least 3 years under our belt, like this is in production for that long, we have some customers egressing a petabyte of, or we have customers with a petabyte of egress in a month. So now that the network is built and we have these early adopters in the system, we can now point those case studies to these newer customers, and they see that it's working. They have they're more likely to try it out because of the success of others. And so yeah, so that's the first part to that answer to that question, is that we were building our reputation and also making sure the network was scalable and ready for this onslaught of bigger data. And then so then the second part of that question is, who are the storage nodes actually? So like I said, they are anyone with unutilized hardware. They can join our network. So here on our forum, you can see there's these node operators. And so these are our people. And I think there's like a show me your storage node rig. I don't know where that one is, but there's people uploading pictures of their servers and what it looks like. So we don't just like if you read our white paper, which is storj.io/whitepaper. Oh, no dash there. White paper. Put that in the chat. We've built in some protections because we can't trust the nodes to not be malicious, right? So that encryption is one layer. Also, when a new storage node joins the network, they have this like month to 2 month vetting period where if they have good behavior, we'll send them more data, etc. And so some people running storage nodes just have a Raspberry Pi and a hard drive with more than like 500 megabytes of free storage. That's one version. Others have more complex setup rigs. So there is some frequent storage node operators in here that share their earnings and how many terabytes. I think some have up to 10 terabytes, some have even more than that. And so they either have great gigabit connections to their homes, or they have access to some data center. So the spectrum is very wide on who the storage nodes are. Oh, awesome. Yeah. So you're saying, I read the white paper a while ago. Frankly, I thought, why wasn't this done sooner? Seemed like such a good idea. Yeah. So we are in pulling in more and more partnerships and customers every month, every week. I've personally worked with Zerto in a couple webinars. IX Systems and the True NAS market. There's been some excitement over there. The True NAS users are like the perfect model for this, because they have those devices where they store their videos, their files, but then they have that unutilized space there. So they're also interested in being storage node operators themselves. And yeah, I personally have been working on distributed storage for roughly 6 years. So predates Storj. I came from Vivint Smart Home, or they spun out a sister company called Crowd Storage, and we basically were able to utilize these hard drives across these homes to store the video clips for the Vivint Smart Home network. So at scale there, we were writing 10 to 15 petabytes a month, had roughly 300,000 nodes. And so Storj is getting to that scale relatively quickly. I think we've added, at least when I joined, there was like 11,000 storage nodes. And we're up to 15,000, I think. So excellent growth. I've been here about a year. So more questions here. So your tech doesn't use much Web3 technologies, right? Is there any scope for sharded blockchains and being added in the future? So yeah, it's often the storage itself is often confused with the blockchain, and so what I typically say is the underlying technology utilizes similar things that the blockchain does, but like the storage, like if you put a 1 gigabyte file in Storj today, it's going to be off chain. It's not going to be in the blockchain network. But we do have our Storj token, which is using the ERC20 Ethereum. So we have that token, which is how the node operators are paid, and it's used as a utility to make the network work in that sense. So is there scope? So to answer the Web3 technologies, so we do have a decentralized network. So those satellites for that earlier graphic can be run by the community. And so the single point of failure isn't on the storage network or the storage company itself. Like the network can exist beyond the company. Still exploring ways to encourage the community to launch out there, but definitely something on the roadmap. Another thing that we recently launched was the ability to have the ability to transfer or pay for storage via smart contract, I think, or to transfer token. Oh, right here. So using ZK Sync, you can transfer money to the storage network and then use that to then further pay for your storage. So the beginning building blocks to like have a smart contract pay for your storage and all that goodness is in the works, and hopefully we'll have some guides and some tutorials on how to use that in the future. Awesome. Great questions today. If you have further questions, feel free to shoot me an email. I am Dan W at storj.io. Yeah, we're coming up on time. I actually quite enjoyed this. Glad that you were able to make it. It's probably getting close to 11:30 p.m. over there in India, but so don't want to keep you up too long. Any plans for virtual machine support to be added in the future? So I think you're referring to this EVM. So we are compatible with ZK Sync, and so that is certainly something to look forward to in the future. The more will be coming soon, but that's something to read about. There is no plans to like develop our own Ethereum. We've actually been pretty happy with ZK Sync for our payments and the Ethereum network for our token. And so what we're focusing on is making the best decentralized storage available to the market at a fraction of the cost without giving up performance. And that's the mission we're on. But awesome. Oh, virtual machines like the ones in AWS. There has been talks about opening up the network to more partnerships. So we have talked to, now I'm going to forget their name, but we are in partnership with like Pocket or Anchor, who have like a virtual machine offering or a virtual node offering for blockchain. So in a similar sense, we've talked to Web3 companies that offer compute in a decentralized way. So that has had a conversation. I don't know if it's materialized to anything. Storj itself, I think for the foreseeable future, we are focused on making the storage the best and scalable with just our current onslaught of customers. And then we will, I'm sure, maybe, I don't want to say no, because it seems like a natural fit to have decentralized storage and decentralized compute somewhere. It may be a partnership that we open up, but I really don't know at this point. Akash, yeah, that is the one. Akash is the one that we have talked to, and actually have done quite a few joint marketing efforts and attended some things in the past. So, yep, Akash plus Storj is an option out there. There's another one that name escapes me, but yeah, great to have everyone out today. Just a reminder that this is every last Tuesday of the month at the same time. So it really relatively chill. You come, ask your questions, and we find answers together. And yeah, thank you so much. We'll see you next time.